Okay, this is MGF1106 Chapter 2, Section 2, which is dealing with subsets. All right. First, the definition for subsets. Set A is a subset of set B, and it's indicated by this symbol here, which is kind of a C with a line under it. If and only if all elements of A are also elements of B. Okay. Some examples of this would be, if you look at example 1 on page 51, here it says, here's set A, Brazil, Argentina, and Peru. Here's set B, Brazil, Argentina, Colombia, and Peru. You can see that Brazil's in both, Argentina's in both, Peru's in both, but set B has Colombia. So set A is a subset of B. As a matter of fact, set A is what's called a proper subset, because if set A is a proper subset of set B, and here the symbol is just a C, not the line under it, if and only if all elements of A are in B, and set A does not equal set B. That is, set A or set B must contain at least one element not in set A. So that's our example here. If we look at this example here, we can see that all the elements in set A are in set B, except for Colombia. So this is set A is a proper subset of B. If we look at letter B, we can see that set B is a subset of set A. If we look at letter C, we have X is all yellow fruit for set A. For set B, X is red fruit. Neither ones are what we call subsets. Okay. If we look at letter D, pink is in both, blue is in both, purple is in both. So set A is a subset of B, set B is a subset of A. If we go to the other two definitions that we have here, we have the definition of the number of distinct subsets. It says the number of distinct subsets of a finite set A is 2 to the n power, where n is the number of elements in set A. So in other words, what it's saying is we want to predict how many subsets we have in a set, then we go 2 to whatever power of elements that we have. That's the potential subsets. Another definition is number of distinct subsets. And if we looked at the number of distinct subsets, it says the number of distinct proper subsets of a finite set A is 2 to the n minus 1 power, where n, again, is the number of elements in set A. So we have the minus 1 because, remember, proper means that the subset doesn't have all the elements that are in the set. So again, if we look at the example problems. All right, there's the first example problem. It says determine whether set A is a proper subset of set B. Well, if we look at this, set A is jazz, pop, hip-hop. Set B is classical, jazz, pop, rap, hip-hop. And we can see that classical is not in both. So all the systems of set A are contained in set B. Sets A and set B are not equal. Thus, A is a proper subset. If we look at letter B on this one, we can see that set A is ABCD, set B is ABCD. They both contain the same number of elements. So this is just set A is a subset of B, B is a subset of A. Come down here, element or subset. So determine whether the following are true or false. Okay, so it says 3 is an element of 3, 4, 5. True. B says 3 is an element of 3, 4, 5. Not true, because what it's saying with the brackets around the 3 for letter B, it's saying 3 is a subset of B. It's not an element. If we go to letter C, it says subset 3 is an element of those, and that's a true statement. Okay. All right. And if you look at D, same thing. Says that is a subset of 3, 4, 5, which is true. 3, letter E, is false, because that is saying 3 is an element. It's not a subset. F is actually a true statement, because an empty set or a null set is always a subset of any set. If we come over here, we're looking at this example problem for distinct subsets. Letter A says determine the number of distinct subsets for the set SLED. Well, if we follow our pattern, we have 2 to the 4th power, because remember the number of elements which are there goes in place at the end. 2 to the 4th is 16. So for the first one here, letter A, there are 16 distinct subsets. Part B says list all the distinct subsets for the set SLED. So all we have to do is start list them in an order. We've got SLED, then we got SLE, SLD, SED, notice we do 4, then the combinations of 3, then combinations of 2, and combinations of 1. Then it says how many of the distinct subsets are proper subsets. And 15 of them are, because the only one that's not proper is the first one, SLED. Now, you've got to make sure you understand these definitions in terms of working these problems. So make sure when you practice these problems that you're following the symbols. Make sure you understand the symbolization here. Make sure you understand that the symbol for a subset is that C with a line under it. Okay. Make sure you understand that the symbol for a proper subset is just C. Make sure you understand that determining the number of subsets is 2 to the n power. But determining the number of proper subsets is 2 to the n minus 1 power. The minus 1, if you look at this example here, this is why it's a minus 1. Because when you figure out 2 to the n, you got to subtract the one subset that will be the same as your set.